Today we will going to discuss unit 3. Unit 3 is on complex integration for real valued function. For real valued function, real valued function, real valued function, real valued function a to b fx dx calculated along the real axis, that is x-axis, from the point x equal to a to x equal to b. But for complex valued function, for complex variable a to b, integral a to b fz dz calculated along the curve joining points along the curve joining points x equal to a to x equal to b. That is, the value depend upon the path joining the point x equal to a and x equal to b. The definite integral in case of complex variable is known as line integral. The definite integral in case of function of complex variable is known as line integral. To discuss in detail complex integral, we need to study some terms. So first is partition. If we divide the interval AB by means of the point T naught, T1, T2 goes on Tn minus 1, Tn, where Tn is equal to B and T naught is equal to A. Then P equal to A T naught, T1 dot Tn is equal to B is called partition of AB, partition of the closed interval AB. The largest of all these subintervals is called of these subintervals. These are the subintervals. That is T0, T1, T2, Tn minus 1, Tn is called norm of the partition P. That means if we divide this interval AB by means of the point A equal to T naught and B equal to Tn, T1, T2 goes on Tn minus 1, then each of this point we'll divide this interval AB, that is, these are small subinterval that are partitions of this interval AB, and each of this subinterval, the largest among this subinterval, is known as norm of the partition P. Next, we will discuss some more terminology. First is differentiable or continuously differentiable curve, then piecewise and piecewise differentiable, then piecewise regular smooth, piecewise regular smooth. So first, we know that this equation z equal to zt equal to xt plus I yt, where t lies between a and b. We have already discussed this equation of curve in our last lectures, where xt and yt are continuous functions of the real variable t. This equation represent arc L in the argon plane. Represent an arc in the argon plane, where xt and yt are the parametric representation of the parametric representation of the arc in the plane. If f z exists and continuous, then the arc L is said to be differentiable or continuously differentiable if f z is not equal to 0, then the arc L is said to be smooth or regular arc. If f z exist and continuous at each of the subintervals, of heavy, then the arc is said to be piecewise differentiable. Said to be piecewise differentiable. In addition to this, if f set is not equal to 0 in each of the subintervals, then the arc is said to be, then the arc L is said to be piecewise regular or piecewise smooth. Piecewise regular or piecewise smooth. Piecewise smooth. With that, I would like to conclude. Remaining will be in the next lecture. Thank you.